All right, this is the notes video for section 1.7, slides 42 and 43. All right, so it says find the slope of the tangent line at x equals a. So we're finding the slope of the tangent line to the graph of f at x equals a. All right, and so what we want to do is we want to evaluate the limit as not x, h approaches 0 of f of x plus h, that would be the square root of 5 times x plus h minus f of x, which is the square root of 5x, all divided by h, right? So, of course, when we plug in h equals 0, we get root 5x minus root 5x over 0, so 0 over 0. All right, now we said we wanted it at x equals a, so we can specifically plug in a for x right now, or we could plug in a for x at the end, all right? So if we're doing at x equals a, then we're going to say, okay, well, then I want the limit as h approaches 0 of the square root of 5a plus h minus the square root of 5a all over h, right? Now, you'll see here that x and a, right, they're really just variables, so it really doesn't matter which way we approach it, but either way is fine, right? Now, if a was a number, right, and we put in like 2 there or 3 or whatever, right, then it looks a little different, but it still is the exact same process. All right, so we're going to have to multiply by the conjugate, right? So we're familiar with this. All right, so we're going to multiply by the square root of and instead of 5 times a plus h, I'm just going to write 5a plus 5h. I just distributed the 5. All right, plus root 5a, and then same thing in the denominator, root 5a plus 5h plus root 5a. All right, so now I'm going to multiply out the numerator. All right, so I have the limit as h approaches 0. All right, so when I multiply out the numerator, right, I'm really multiplying the square root of 5a plus 5h times itself. So that's just going to give me 5a plus 5h. All right. And then I have the minus root 5a times root 5a plus 5h, and then the plus root 5a times root 5a plus 5h, right? So those subtract out. Then I have minus root 5a times root 5a, all right? And so I'm just going to get 5a, right? And then divided by, I do not want to distribute the h because we know since h is approaching 0, we're ultimately going to get h to reduce, all right? And so then I'm going to leave the square root of 5a plus 5h plus root 5a. All right, so now I'm going to drop the parentheses in the numerator because those don't do anything. And then I have 5a minus 5a, so those subtract out. So I'm left with the limit as h approaches 0 of 5h over h times the quantity root 5a plus 5h plus root 5a, right? So now, of course, like we said, h must reduce. And so we're left with the limit as h approaches 0 of 5 divided by the square root of 5a plus 5h plus root 5a. And so now I am ready to reevaluate. Remember, now we're going to plug 0 in for h. So I get 5 over 5a plus 0, right? So that's just going to be the square root of 5a plus the square root of 5a, right? And so I get 5 over 2 root 5a, right? And so that would be the slope of the tangent line at x equals a. Now, of course, if we said, well, at x equals 2, then we would plug 2 in for a, right? And you could plug 2 in for a at the beginning or at the end, either way. All right, so that's slide 42. All right, and then slide 43. All right, so first of all, we want to define the normal line. Okay, the normal line is the line perpendicular to the tangent line. Okay. Now, for those of you who have taken physics, you recognize that the normal force is the force that is perpendicular to the plane in which you're resting on. All right, but basically, all right. So let's say we have like a circle here, and we have a tangent line which is right here. Then the normal line is the one that is perpendicular through it, which would go into the center of the circle. All right. So it's important to remember the definition of perpendicular, right? So what is that? Remember, tangent and normal, they would have slopes that are opposite reciprocal, right? So if the slope of the tangent line is 2, then that means the slope of the normal line. And I tend to write it like this, like m tan and m norm. All right, so the slope of the normal line would be -1/2. All right. So write equations of the tangent normal lines at x equals -1. All right. So what we're going to do is we're going to use our limit as h approaches 0 to find the the slope of the tangent line. All right, and then we're going to use that to find the slope of the normal line, and then we're going to write the equation of the tangent normal line. All right, so first of all, I'm going to find the slope of the tangent line. So m tan is going to be the limit as h approaches 0 of what? F of x plus h. So x in this case is -1. So I'm going to do -1 plus h squared plus 5 times -1 plus h plus 6, right? That's f of x plus h minus f of x. So that would be -1 squared plus 5 times -1 plus 6, all right? And then all of that divided by h, right? All right, so now we've got a little bit of work here. All right, -1 plus h squared. Remember, that means -1 plus h times -1 plus h. And so we get +1 minus 2h plus h squared, right? Then I'm going to distribute the 5. So I get -5 plus 5h plus 6, right? All right, and then here I'm going to do all of this at once. -1 squared is 1 minus 5 plus 6. So 1 minus 5 is -4 plus 6 is 2. And so I just get a -2. All right, and then all divided by h, and then I have the limit as h approaches 0. All right, so now on the top, okay, we know that everything without h must subtract out because remember, then h is going to need to factor and reduce. All right, so now we want to make sure that everything without h is going to factor out. So I have a 1 minus a 5, which is a -4, plus a 6, which is 2, minus 2. So those all do indeed subtract out. And then I also have some h's, which can simplify, right? Because I have a -2h and a 5h. So that's going to give me a 3h plus h squared, right? And then divided by h. So now you can see that the limit as h approaches 0, we are going to be able to evaluate it because now h can factor out. So 3 plus h over h. So h reduces. So now I'm left with the limit as h approaches 0 of 3 plus h. So then I can evaluate with h equals 0, and I get 3. So remember, what did we just find? We found that the slope of the tangent line is 3. So let's just write this, okay? M tan is 3. So that means that the slope of the normal line is -1/3. All right, now, in order to write the equation of a line, I need two things. I need a point and a slope, right? So remember, we have to find the point. All right. So the first thing that we do is we have to look at the x value. All right. So the x value is -1. And then the y value, well, the function value is f of -1, which we actually did up here, which is 2. So the point is 1 comma 2. All right. And so that means the equation of the tangent line, okay, is going to be found by taking y minus 2 equals slope of 3 times x minus -1, so x plus 1. So that's the equation of the tangent line. And then the equation of the normal line is using the same point, but now we're using the slope of the normal line. So y minus 2 equals slope of -1/3 times x plus 1. All right, and so that is slide number